Hi, and welcome to the BioPharma Finder 2.0 help video. In this video, I'm going to demonstrate some of the new features for the peptide mapping workflow. Here you see the process and review page for a peptide mapping experiment. And in this experiment, I processed the NIST standard antibody, and I have two raw files. I have a reference, and I have a sample. And in this case, a synthetic peptide was spiked into the sample that is equivalent to a sequence variant. And so it was a tryptic digest, and we processed it using the normal peptide mapping workflow. And I'm showing you right now the SIC traces for both the reference and the sample, so we can compare the two different SICs. So here you'll see the table down below, and I can apply the filters. So I'm going to show you get rid of all the non-blanks. So now we can see all the peptides. And again, this was a sequence variant, so if I do non-blanks, I can do that. This was the actual spike, so if I zoom in, you'll clearly see right here, this is the peptide that was spiked in, and it's not present in the reference. So this is the actual sequence. If we do this, you can see where the sequence actually elutes. And what we'll do is I'm going to show you how we can find the non-modified. So I'm going to say contains. It takes just a second here for my computer screen to come back. Just not too sure why it's doing that. There we go. Just pop that out there. That gets it back in. Okay. So let me go ahead, and there's something with my memory going on here. So if I start to type the sequence of the peptide in the contains, and I get rid of this, that peptide sequence is going to show up. Okay. So let's keep on going here a little bit further. SQ. Okay, so now we have a whole bunch of different versions of the peptide, and okay, so here we have the sequence variant, and that's the +2, and then we have the non-variant. So, and if you follow the sequence, it is the N is converted to an S. So the 157, so it's this N right here has now become an NS. Okay. So, we see the normal form in both files, and it elutes at like 17 minutes. And then the variant elutes a little bit later, so there's a shift in the retention time. So we're going from 17 minutes to 18 minutes. You can see the MSMS spectrum. So here is the MSMS spectrum. This is the experimental. This is the predicted. What I like to do sometimes is I like to put these beside like that because they're floatable. And then you can actually see the coverage right next to the MSMS spectra. So this is for the +2 of the non-modified. And then if we click here on the +2 for the modified, now you'll notice that you don't see anything. So what you want to do is expand this and click down. So the reference file, because it wasn't in there, didn't have an MSMS. But the sample did. So we can click down here at the second level to get to the MS2 spectrum. And then you can see your Y and B fragments. And so this is the residue, I believe, that was actually shifted. So we can actually see if we got the appropriate ions for our modification. So that looks very nice. Now, what if we want to figure out how much? So what is the abundance of this modification, and how much of it is actually present for this sequence variant. So what you can do is you could export out, because first of all, you could check these, and you could export, you could export this out to Excel, and then you can look at the information in there, or you can go to the mapping tab. Let's give my computer a break here. Okay, there it goes. Okay, so now we're in the modification summary. And the modification summary is going to tell us how much. So what I'm going to do for right now is I'm going to throw this back here so you can see it easier. And I'm going to put this one back here too. Okay, so Remember, you can move these windows around all over. So there's our modification. Here's our results. This way you'll be able to see it a little bit better. And this modification summary is done by site. So it's when we talk about a modification and how much the relative abundance per sample or per condition, so we have a reference and a sample, it's going to be by the location. So M4 of the light chain, and you can pull this out to actually see, it gives you the M4 oxidation is at this percentage. Okay, so categories, it will have a category for sequence variants, so you can quickly filter and get right to your sequence variant. So when you click on your sequence variant, when you click on this row, down below you're going to have the components that were actually used for the calculation. You'll also see all the components that contain that residue. So the residue at 157, what you see down here are all components or peptides that contain the residue of at 157. Okay, so there's 19 of them. And there's a whole bunch of different forms that the software identifies because it tries to identify everything. So you'll see gas phase fractionation, you see sodium, potassium, non-specific, and there's a whole bunch of different things. And they range in different abundances and different charge states and all that. So the software has to determine what to use for the calculation to actually determine the percent abundance. And so what it's done is it has some rules that it defines. And those rules are a series of parameters. So if you right click up here and you go to the summary option, you'll see the rules. And so these are the different rules that the software is actually applying. So it's trying to compare peptides with it's a minimum intensity percentage. So we don't want a lot of really low abundant peptides interfering in the calculation. We also want to make sure that we're comparing the same charge states. So are we comparing, so if we have a really abundant non-modified peptide and our modification is very low, we want to make sure that we balance out the charge states so that we're not underrepresenting our modification. So that's basically what these rules do. Now, when you first open up the software, you're going to see that these are bolded. So they're bold and blue, and they're also checked. These were the peptides or components that the software selected for the default calculation. So that's what you see up here. Now, the way it comes up with this calculation is it's actually going to use the MS area. And so it's just a ratio calculation. And if you, it's a per raw file. So let me expand this, might be easier. There's so much information. Okay, here, you can see it right here. So the percent abundance for the reference file would be the modified peptides. So it would be taking this one, and this one. It would be taking the area from these three, that's the numerator, summing them up, and then it divides that by the area of all of these. Okay, and it's MS area of the full scan data. So it's this value right here. Okay, so it's MS area of the full scan. So let me go over that again. So the percent abundance for the reference file, that would just be the reference raw files, is going to sum up the MS area from the reference files for the modified, which would be these two. And then it's going to divide it by the sum of all of them. Okay, so it's going to use all the ones that were in blue. So that's how it's actually doing it. And it does that for both of the two different conditions. And then you get a value. Okay, so now, but you as a user, you might want to control what gets used. So you may say, well, I don't want to use this one. Why did it select that? That's got an NH3 loss. Why is that considered an unmodified? It's modified with something else. I don't want to use that. And then you can say, well, let's use this one. So this is the +3, +2, +2. Well, maybe I just want to use the 2 +2s. Or maybe I'm just going to take the most abundant of them. So you could sort by area, MS area maybe. And you could just do that. You could say, well, that's the most abundant, non-specific, or that's the most abundant unmodified, And then you're going to come down here till you see the most abundant modified. You're going to use that one. Okay, so that's what we're. So you can make whatever you want, rules about whatever you want now. Check them. So those are the ones that you're going to use, and you hit recalculate. And so now what the software has done is it's using whatever value you tell it to use. Okay, so it's changed, and it'll say whatever you like. If you click on here, you'll notice that it's, actually, let's save it. So we need to save it. And so when you're telling it to do your calculation, it's ignoring these, and it's using the values that you tell it. Okay, so it's ignoring the parameters, but it's using the components that you actually tell it. So now that you have that in there, you can save it. So you saw that it said to save it. Here, let's try another one real quick. Where is that oxidation? Let's just pick on this one. It's taking it a few seconds. So in this case, you can see that we have 2 for the 2 and the 3, the 2 and the 3. So let's just say we want to do the 2. We don't want to do the 2 and the 3. And you hit recalculation. And so you'll see that you're getting these new values, and then you save it. And then when you come, you can sort by the new values. You can also export this, and it will show your customized values. Now, the other thing is it won't remember what you've done. So this is pretty manual at this point. But I think this is, step one in giving you a little bit more control over how to control the quantitation and relative abundance of what's in here. What I hope happens is that you'll start to realize that the values that the software does by default are pretty similar to what you have been calculating by hand. I hope that's what actually comes out of this. Something else I want to show real quick, just to explain what the normalized time shift and predicted time shift is. The normalized time shift is, it's looking at, let me show you here. So it's looking at the shift in chromatogram of the modified versus the non-modified. So for example, if we look here, the oxidized form of this peptide is eluting earlier. So it elutes at 28, and this one elutes at 35 minutes, the non-modified. So this is saying that experimentally the data is showing us a negative 17.7%. And when it's negative, that means that the modified is eluting earlier than the unmodified. Okay, so this is experimental data. This is predicted data. So the software is going to try to predict based on the modification and the residue what would actually happen, just based on hydrophobicity of the modification. And so here he says it's going to be about 10% earlier. And so if these two match, and the degree doesn't have to be exactly the same, but the direction should be the same. It does give you more confidence in your results. So for example, in our sequence variant example, we said that experimentally the data is showing that the modified form is eluting a little bit later, and that's what the predicted shows as well. So as long as they're going in the same direction, about the same degree, that's a really good evidence that supports the actual observation. So that might be useful. And then you can also, one thing that you could do too is, like for this example where we're looking at an oxidation, if it does turn out that any of the oxidations could be in-source oxidation and the software is maybe labeling it incorrectly, that could be giving you a higher percentage of oxidation. So now what you would be able to do, and I don't know if this is actually the case, but let's just say, for example, that these two might actually be in-source oxidation. That's why they're co-eluting with the unmodified. We could uncheck those to rule those out and recalculate, and then it's going to show a more realistic amount of oxidation that's occurring. So it's another way that you can look at your data in a little bit more detail. And the software does try to determine, and it will label if it's in-source oxidation, but sometimes it doesn't get it correct. So sometimes the peaks have to be exactly the same for it to really classify it correctly. But this is a way that you can adjust that, and if that does happen, you can help the calculation out. Okay, great. I hope you find this new feature beneficial, and please check out the other videos for how to use BioPharma Finder. Okay, thank you.